So now we'll start lesson 2, which is nomenclature. When we are talking about nomenclature, is naming. In other words, is naming. So what are we covering on this is a nomenclature of ionic compounds and a nomenclature of molecular compounds with all the subtopics. So single valence, multivalent, and polyatomic ions. And as well, when we are talking about molecular compound, in which cases are we using prefixes and in which cases we are not. Let's start with ionic compound. So ionic compound are formed as a combination of a metal with a non-metal element. Metals, as we said, even when we were explaining ionization, have the tendency to lose electrons, and they are becoming positively charged, while non-metals have the tendency to gain electrons, becoming on this way negatively charged. And when we are saying positively, and so now we have two ions, one that is positively charged and the other one that is negatively charged. You know, even from the general law of electricity, that two opposite charges will attract each other. So as soon as we see that we have sodium here that is positively charged and we have chlorine here that is negatively charged, they will attract each other and will form that is known as attract each other, and forming that is known as the ionic each other, forming that is known as the ionic compound. So this is telling us that an ionic compound is formed by the combination of a metal and a non-metal. You probably have heard this even from the Science 10 teacher that was saying that in your periodic table, if two fingers are apart when you are composing a compound, then it's an ionic. And when two fingers are close, then you are dealing with a molecular compound. Now, what we will review is how are we going to name them? And this is where the having periodic table in front of you will help. So the first part is when we are having that is known as the single valence electron. What are metal? What are those single valence elements? If you see in the periodic table, right below the atomic mass, you will have on some elements, you will have +2, +3, +1, +2, +3, +4, and so on. If you have more than one of those numbers, that means that you are dealing with a multivalent metal. But on the case when you have, let's say, lithium, right below 6.94, you have only +1. That means that you have lithium is a single valent metal. Sodium +1 is a single valent metal. Magnesium +2 is a single valent metal. But when it comes to chromium, let's say that is on the 24th place of the periodic table, you have +3, +2. That means that chromium is a multivalent metal. Now, the first part will deal with the elements that are single valent. So the elements like lithium, beryllium, sodium, magnesium, calcium, potassium, aluminum, gallium, zinc, germanium, and so on, that have only one number below the atomic molar mass. Let's see now, how are we naming those ionic compounds? We are naming them with the name of the metal, so the one that is below the staircase, and the root of non-metal plus IDE. So in this case, the name will be sodium chloride. The chemical formula for this will be NaCl. Lithium bromine, lithium and bromine, okay? So lithium is +1. When you see it here, it's +1. Bromine is on group 17, which means that bromine will be -1. Okay, it will have 7 in the outer shell and will have the tendency to have one more to complete 8. So when those two are combined together, what will happen is those charges will switch places. Okay, so lithium will be 1 and bromine will be 1. But in chemistry, we do not write 1. So the chemical formula for lithium and bromine, or lithium bromide, will be LiBr. And the English name for this will be lithium, the name of the metal, bromide. Brom, that is the root of bromine, and IDE that we add to identify the ionic compound. Potassium and oxygen. Potassium is K+1. Oxygen is on the 16th group. So that means that we'll have 6 electrons in the outer shell. So when it completes the outer shell with 8, will be 2-. So those switch places, and then this becomes K2O1, which we do not write, so will be K2O. And the name will be potassium oxide. Magnesium and oxygen. Magnesium is 2+, oxygen is 2-, so those coefficients are switching place. Will be Mg2O2. In the simplest form will be MgO. The name is magnesium oxide. Okay, next one, beryllium. So beryllium is 2+, fluorine is on the 17th group, meaning that it has 7 electrons in the outer shell. In order to complete that with 8, we'll need 1 more electron. So now we switch, and then we'll have Be1F2. Since 1 is not written in math or chemistry or science in general, will be BeF2. And the name for it will be beryllium fluoride. Calcium and oxygen. So calcium is +2, oxygen is -2. Take those two, switch the places, calcium 2, O2. In the simplest form will be CaO, which is calcium oxide. Barium and sulfur. Okay, barium is 2 plus, sulfur is on group 16, so will be 2 minus. It has 6 in the outer shell, it needs 2 to complete the outer shell. Take those coefficients, make them Ba2S2. In the simplest form will be Bas, and the name will be barium sulfide. Magnesium and selenium. Okay, magnesium is 2 plus, selenium is 2 minus, and this will be MgS, and the name is magnesium selenide. Beryllium and oxygen. Beryllium 2 plus, oxygen 2 minus, so will be BaO, and the name will be beryllium oxide. Do you have questions? Let's take a look at now at the multivalence element. So are the elements, as I said, that have 2 numbers right below the atomic molar mass. So let's say manganese, that is on the 25th place of the periodic table, has a +2 and +4. That means that we have to identify which one are we using. Are we using the +2 or are we using the +4? So in the first case, when we have titanium valence number 3, titanium 3 and fluorine, then this will be titanium is on the 22nd place on the periodic table. So titanium will be +3. You have the option, since it is multivalence, to say, is it +3 or is it +4? And since it is 3, then will be +3. And fluorine, that is on the 17th group, has 7 electrons in the outer shell, will need 1 electron to complete, so will be -1. So now 3 goes here, 1 goes there, and then we'll have titanium F3. And the name will be titanium, specifying what valence is it, titanium 3 in Roman letters. Fluoride. Okay, the root of the non-metal plus the IDE. When we move to manganese now, manganese has 2 as +2 and +4. The one that we have to take into the consideration is +2. So will be Mn 2 plus. And then we have chlorine. Chlorine is on the 17th, which means that it has 7 electrons in the outer shell. That means that we'll need 1 more electron to complete it. So switching the places, this will turn into MnCl2. And the name for this will be manganese you have to specify is manganese 2 chloride. Iron is the same deal. Iron has two valences, +3 and +2. So in this case, it's +3. So will be iron 3+, and sulfur is on the 16th place of the group of the periodic table. That means that it has 6 electrons in the outer shell and will need 2 more to complete the 8. So this will turn into Fe2S3. And the name for this will be iron. We have to identify which valence are you using. Iron 3 sulfide. Okay. Next one is chromium. Chromium has a +3 and +2. So this is telling us that it's chromium 2. So chromium 2+, and oxygen, as we have mentioned several times, 2-. So will be a CrO, and the name will be chromium 2 oxide. Does it make sense? Okay, so now when we are talking about polyatomics, first of all, where are polyatomics? Polyatomics, the table of polyatomics in almost every periodic table is right below, above right above that gap that is in the periodic table, that depth that is in the periodic table. So polyatomic ions, since the word ion is saying that they will have charges, but they act as one group, okay? And when we have a polyatomic that is formed in an ionic compound, the rule that we follow is a metal and whatever is the name of the polyatomic. We don't change it, we keep it as it is. So on the case, so when we have beryllium, beryllium is +2. And then we have phosphate. So in the periodic table, we will find where is phosphate. And phosphate is PO4 3-. So they act as one group, okay? You don't break them. And in order to show that they act as one group, we use brackets. So we take that 3 and bring it to beryllium. We take that 2 and bring it to phosphate. So this will be Ba3, PO4, that acts as 1, 2. And the name will be beryllium phosphate. Beryllium phosphate. So we don't change the name of the polyatomic. We keep it as it is. So lithium and fluorine. Okay, this is not fluorine. Let's change it into polyatomic. Let's say dichromate. This is not a polyatomic. Fluorine is a element in the periodic table. So let's say now that we have a lithium and dichromate. So lithium, as you see in the periodic table, is +1. Let's find dichromate. Dichromate is Cr2O7 2-. Okay, so we take this and we bring it here. We take this and bring it here. The polyatomic act as one group. You cannot break it. And in order to show that they are acting as one, you use brackets. So it is lithium 2 Cr2O7. It's 1 if we are going to be specific, but then 1 is not written in the chemical formula. So Li2 Cr2O7. And the name will be lithium dichromate. No, we don't change it. Magnesium and sulfate. Okay, don't mix it up with sulfur or anything like that. Okay, it's sulfate. So magnesium is 2 plus. Sulfate in the periodic table on the table of common polyatomic ions will be SO4 2 minus. Switching the places will be MgSO4, and the name will be magnesium sulfate. Even when we have polyatomic, multivalent, we just state what is the valence of the metal. So in the case when we have an iron 3, then will be iron 3 plus, and iodate, where is iodate here? Iodate is IO3 1 minus. So now, as I said, polyatomic act as 1. So this 3 will affect the whole thing, and this 1 will affect iron. So will be FeIO3 3. And the name will be iron 3 iodate. Does it make sense? Another important skill for you to know in terms of the review of Science 10 is when we have the name and we want to write the formula. So in this case, we have copper, and copper is, it's copper 2, so Cu2 plus, and we have chlorine. Chlorine is 1 minus, so we switch the place and the chemical formula will be CuCl2. Lithium acetate, as you notice here, acetate is not a common name for the elements of the periodic table, so the clue will be that you will have to deal with polyatomic. So lithium, for this one here, lithium is +1, is a single valence, and acetate in the common polyatomic ions table is CH3COO 1 minus. So the formula will be LiCH3COO. Manganese for nitrate. So manganese is, and it's 4, so 4 plus. And a nitrate in the common polyatomic table. Okay. Oh, it's nitride. Should be T. Should be T, not D. Nitrate, NO3, NO2. Sorry, NO2 1 minus. So the formula will be switching places. N1, which we don't write, and NO2 4. beryllium oxide. So this means that you are having beryllium and oxygen. Beryllium is +2, oxygen is -2, so BaO. And so you continue with the rest of them on your own. So now we'll move to the molecular compounds. In terms of naming, molecular compounds are a bit easier than ionic. They are the same, but yeah. Molecular compound is formed when two non-metal are bonded together. In a difference with ionic compound, molecular compound share, and we will talk about this in the next unit, right after the review, share their valence electron. So when we have in an ionic compound, the electrons are, metals are losing, non-metals are gaining, and then in this form there are two objects, ions in this case, that have different charges that are attracted between each other, forming ionic compound. On the case of molecular compound, what is happening is the electrons are shared between the two non-metals. And as I said, the focus of next unit is this. And when we are naming molecular compound, we are using prefixes, which are letters or way to show how many of each atom the compound has. If it is mono, means 1. If it is di, means 2. If it has 3 atoms, then we say 3. If it is 4, then we say tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. 10, deca. So we are defining how many atoms, how many number of atoms we have on the compound. Okay, so the first part is when we are using the rule is the prefix, start with the prefix of source, number element, okay? Start with the prefix of the first element, unless it is 1, and then followed by the second element, the prefix of the second element, and IDE. So we have here N2O, okay, 1. So 2, we said that is D, Di, okay? D, nitrogen, monoxide, okay? Now we have sulfur, 3, oxygen, 2. So we'll go 3 for 3 here. 3 sulfur, D oxide, 2 nitrogen, 4 hydrogen. So D nitrogen, and 4, we said that 4 is tetra. Okay, tetra. The root of hydrogen is hydro. So it will be hydrate. And in this case here, we have 3 hydrogen and 1 sulfur. Okay, so for 3, we have 3 hydrogen mono sulfide. In this case here, this is peroxide, in other words. 2 hydrogen, 2 oxygen. So D hydrogen, D oxide. This is water in common language, but it is H2O. So D hydrogen monoxide. Okay, next one. Carbon and oxygen has 2. So now, on this case, we do not state the mono. If it is 1 for the first one, we don't state the mono. So we just go carbon, dioxide, carbon dioxide, oxide. Yeah. Okay. So now we have from names to the formula. So we have the first one is nitrogen, and it has 1. How do we know? Because if there is 1 on the first element, we don't mention it. And then monoxide, oxygen is 1. D nitrogen monoxide, and 2 O. D chlorine heptaoxide. So chlorine is 2, and hepta in the table here, you have to remember this table, guys, is 7. So will be O7. D sulfur, D chloride. So sulfur 2, Cl2. Tetra is 4. Phosphorus, D, should be D. Deca. Okay, it's deca. Deca sulfide. So P4S10. Tetraphosphorus, nona sulfide. So P4S9. B nitrogen pentaoxide, penta is 5. So N2O5. Nitrogen monoxide, so again, there is no specifying here means 1. And O, sulfur hexafluoride, so sulfur, no prefixes here used, so it's 1. Hexafluoride is 6. Iodine, no prefix here, so means 1. Hepta is 7. Fluoride, F7. Okay, you can practice on your own on those practice questions here, and then you will identify the mistake on those ones here. Keep in mind, and this is very important, that we have those that are known as the polyatomic elements. What I recommend you doing is printing out the data booklet and then having information that are important on the very last pages of the data booklet. On the very last pages of the data booklet, you will see an opportunity for you to take notes. Okay, this page here. You will see an opportunity for you to take notes. Print this out as well, and then start with putting there important information. Like this table here is important need to memorize along with this table here. Which means I will suggest you to have it in your periodic table here on this page, on the last page of the periodic table. Okay, so you will practice on those ones here, and then we'll check your understanding. And this is the end of this lesson. Okay. As soon as I share this digital notebook with you, please complete those, check your understanding. And as I said, they are not for marks. It's for me to know what should I emphasize my lessons on the following day.